The aircraft carrier USS Gerald R. Ford, CVN-78, along with its escorts and embarked carrier Air Wing 8, has been redirected from its current operations in the Caribbean to the Middle East as part of a broader U.S. naval reinforcement in the region. Operating in Caribbean waters in recent months, the Ford is now expected to link up with the USS Abraham Lincoln Carrier Strike Group to strengthen American maritime posture amid rising tensions. The strike group originally deployed in June and was later shifted from the Mediterranean to the Caribbean, where it had been supporting U.S. Southern Command missions since mid-November. According to reports, the carrier was already on station in early January when U.S. forces conducted an overnight raid in Caracas that resulted in the capture of former Venezuelan President Nicolás Maduro, with aircraft from the Ford providing operational support. Ford's crew received word of the revised deployment orders on Thursday, February 13th. The ship's company had been expecting to head back to home port in about 2 weeks, but the new tasking will extend the mission significantly, potentially making it one of the lengthier deployments in recent U.S. naval history. We have received a lot of comments regarding Iran's high-speed anti-ship ballistic missile threat in our last video titled, "How much damage can USS Gerald R. Ford inflict on Iran in 24 hours?" There are concerns that the supercarrier could be at risk. While concerns are natural and any rival must not be taken casually, U.S. Navy has a weapon to counter this scenario. In this video, Defense Updates analyzes how SM-6 nullifies Iran's high-speed anti-ship ballistic missile threat. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. Iran has invested heavily in anti-ship missile capabilities as a core component of its anti-access area denial A2AD strategy in the Persian Gulf and Northern Arabian Sea. Rather than competing ship for ship with the U.S. Navy, Tehran has prioritized a layered maritime strike architecture built around coastal batteries, fast attack craft, submarines, and increasingly capable high-speed anti-ship missiles. Several missile systems, particularly near hypersonic and quasi-ballistic designs, are assessed to pose credible operational challenges to U.S. carrier and surface strike groups operating in the region. At the center of concern are Iran's high-speed anti-ship missiles, which combine velocity, maneuverability, and distributed launch options. Systems such as the Khalij Fars, Hormuz 1 and 2, and variants of the Fateh 110 anti-ship ballistic missile family represent a shift beyond traditional sea-skimming cruise missiles. These weapons follow a quasi-ballistic trajectory and can reportedly reach speeds in the Mach 3 to 5 class during terminal approach. High closing velocity compresses the defensive engagement timeline for U.S. naval forces, placing a premium on early detection, tracking fidelity, and layered interceptor response. The Khalij Fars Persian Gulf missile is widely viewed as Iran's most prominent anti-ship ballistic missile, ASBM. Derived from the Fateh 110 short-range ballistic missile, it is believed to have a range on the order of 300 kilometers, approximately 185 miles, and uses electro-optical or infrared terminal guidance to home on maritime targets. Iranian sources claim a maneuvering re-entry vehicle designed to complicate interception. Zulfiqar Basir, with a speculated 700 kilometers, 435 miles range, is another weapon which has been talked about. While independent verification of real-world maritime targeting performance remains limited, the kinematic profile of these systems alone forces U.S. planners to treat these as a serious contingency threat in confined waters. The SM-6 is the latest evolution of the U.S. Navy's long-standing Standard missile lineage that dates back to the 1960s. While the missile retains the highly reliable SM-2's aerodynamic body, it integrates modernized avionics, advanced processors, and an active radar seeker derived from the AIM-120 AMRAAM air-to-air missile. This blended design approach provided engineers with a proven flight platform paired with cutting-edge guidance technology. Marrying the AMRAAM's active seeker to the SM-2's propulsion and airframe enabled a major leap in capability. Unlike earlier standard missiles, which depended on continuous target illumination from the launching ship, the SM-6 can guide itself during the terminal phase. Once it closes on the target, the missile's onboard radar takes over, allowing autonomous homing. This greatly enhances tactical flexibility, particularly in saturation scenarios where ships must engage multiple threats simultaneously. In terms of physical characteristics, the SM-6 is approximately 6.6 meters long, with a diameter of about 0.53 meters. Launch weight is roughly 1,500 kilograms, around 3,300 pounds. Propulsion is provided by a two-stage solid rocket system. An initial booster delivers rapid acceleration after launch, while the sustained motor carries the missile to its intercept envelope. Open-source estimates place its top speed above Mach 3.5, enabling rapid closure against both high-altitude and sea-skimming targets. The interceptor is equipped with a blast fragmentation warhead triggered by either proximity or impact fusing. Although optimized for anti-air warfare, testing has demonstrated the warhead's effectiveness against certain surface and land targets as well. The combination of high velocity, precise terminal guidance, and a substantial explosive payload gives the SM-6 the ability to neutralize a wide spectrum of threats. The missile is deployed from Mark 41 VLS, vertical launch system, cells allowing it to coexist with other weapons such as the SM-2, SM-3, and Tomahawk. The Arleigh Burke-class destroyers and Ticonderoga-class cruisers accompanying and protecting the supercarrier have 96 and 122 VLS cells respectively. The SM-6 uses a layered and highly adaptive guidance architecture. After launch, the missile relies on its inertial navigation system, INS, to follow the planned flight profile toward the target area. During the mid-course phase, it receives in-flight corrections via a secure data link from the firing ship or another network sensor. These updates enable the weapon to continuously refine its trajectory as the tactical picture evolves. In the terminal phase, the SM-6 activates its onboard active radar seeker, allowing it to independently search for and engage the target. The missile also retains the option for semi-active radar homing if the launching platform elects to illuminate the target, giving commanders flexibility across different engagement geometries. This multi-mode guidance scheme allows the missile to prosecute threats well beyond the radar horizon of the firing ship by leveraging off-board targeting data. One of the SM-6's most important advantages is its deep integration into network-centric warfare frameworks. Fully compatible with the Aegis combat system, the missile can ingest targeting information from a wide array of platforms, including other ships, airborne early warning aircraft, and land-based sensors. This enables the engage on remote construct, in which a surface combatant can fire at a threat it cannot directly detect with its own radar. This distributed sensor shooter model significantly extends the defensive footprint of naval forces. A destroyer or cruiser armed with SM-6 interceptors can contribute to the protection of the wider task force, nearby commercial shipping, or even coastal infrastructure against long-range aerial threats. In joint force scenarios, the missile can also be cued by sensors from the U.S. Army or Air Force, reinforcing its role as a key node in integrated air and missile defense architectures. A defining feature of the SM-6 is its multi-mission flexibility without requiring physical reconfiguration. In the anti-air warfare role, the missile is capable of engaging hostile aircraft and cruise missiles at ranges reported to approach roughly 460 kilometers, about 290 miles. In its terminal ballistic missile defense mission set, the interceptor is used to destroy incoming ballistic threats during their atmospheric re-entry phase. While not directly relevant to this video, viewers may note that recent developments have turned the SM-6 into a high-speed anti-ship weapon. Since its introduction, the missile has undergone an extensive series of flight tests and operational demonstrations that provide a clear picture of its maturity and evolving role. Overall, the SM-6 has built a strong performance record, though its more advanced missions have required incremental refinement. One of the SM-6's most publicized achievements came in the mid-2000s, when the Navy confirmed it had executed the longest-range surface-to-air intercept in its history. This milestone underscored the missile's primary mission: long-range fleet air defense against advanced aircraft and cruise missiles. Follow-on exercises showed the missile could handle complex raid scenarios, including multi-target engagements. In these air defense roles, the SM-6 has demonstrated high reliability and is now widely regarded as a mature and operationally credible interceptor. The most technically demanding mission for the SM-6 has been terminal ballistic missile defense. Initially conceived mainly as an air and cruise missile interceptor, the missile's ability to engage ballistic targets in the atmosphere required additional development. A major breakthrough came in 2017 when an SM-6 successfully intercepted a medium-range ballistic missile, MRBM, target during a U.S. Missile Defense Agency test. This demonstrated the feasibility of using the missile as a lower-tier complement to the exo-atmospheric SM-3 interceptor. However, progress in the BMD role has not been perfectly linear. Some later flight tests revealed integration and software challenges, particularly as the Navy pushed the missile into more stressing engagement conditions. These issues prompted upgrades, most notably the SM-6 Dual 2 configuration with software upgrade SWUP. This version is optimized for terminal ballistic missile defense while preserving the missile's multi-mission flexibility. Recent testing suggests the upgrades are paying off. In 2023, and again in 2024, Aegis destroyers successfully intercepted MRBM targets using the SM-6 Dual 2 in salvo scenarios. These events are especially important because they demonstrate not just single-shot success, but coordinated engagements under more realistic combat conditions. It is evident that SM-6 is well tested. So, while Iranian anti-ship ballistic missiles are a threat, those can be handled. The large number of combined VLS cells in the carrier strike group will ensure protection even if Iran manages to launch a barrage of missiles. It is also to be noted that unlike some notions, pinpointing location of a supercarrier in an open ocean is not easy, and hitting a maneuvering warship is even harder. Further, U.S. military will likely conduct preemptive strike on launch pads and storage facilities of these missiles to reduce threats.